Good evening, sir. How are you?
I don't think his mic is working.
Oh, or he's just connecting. Guys are connecting to audio.
No man, I have been here for about 20 minutes now, and he's been like
And
that.
he has been connecting since?
Yeah,
Okay, good evening.
even.
Hi guys, good evening, and how are you doing today?
I'm good, sir. How are you?
Hmm. Feeling a little tired, but I'm good. Otherwise, can't complain.
So like
All
you're
right.
having flu, sir.
I don't know. I'm wondering why is it I'm so nasal? Yes, the Korean with
The
maybe
remedy
sleep,
for
but
that, you know,
what?
the honey,
Oh, I have some, you know. Which one? The one that come in the bottle?
the one that comes from the bees.
Your teacher was just being rude. But yes.
No, I'm not being rude. You
No,
say the one that
I
comes
said
in the
your
bottle.
teacher. I said your teacher was just being rude.
I
Which
sell
other
it in the
honey could
bottle
be talking
and I
about?
sell it in the jar.
Which tell me now, which other honey we could be talking about? Cactus one?
You know, probably.
Yeah, but I'm feeling nasal and I'm sounding a little nasal. But I have an important question to ask of you. This is now Wednesday into the second week of school. Outside of your general courses, maybe like administrative comm or maybe introduction to HRM or whatever it is. When you look at a core specific, how many students are you seeing that are either BDIT or BMIS?
So I can't answer that because I wasn't at class yesterday. I don't have any internet and I still don't. So I'm sharing the hotspot from my phone. So I won't be able to tell you what happened yesterday.
Well,
And
clearly, because you never tuned for no other class but your Calculus 1 class yesterday, so I'm no surprise.
so that's not what it is. I came home, no internet. Sit down there, I don't
No,
have a call flow because I don't know what's going on.
Nikki, have to remind you, say, hey, yo, don't rush it, you know. Class up on Wednesday and Thursday. But anyway, it's good vibes, all good vibes, all good vibes. All right.
Yeah, I
So
just
only
thought
three
that
of
we
us
had
here.
it on Tuesday.
Say it again, love.
I was saying I just thought we had it on Tuesday as well. Tuesday and
Oh,
Thursday.
Tuesday and Thursday. That's how the timetable was some many years ago. So I want to tell you what you did to me yesterday when you said, sir, um, whatever. I was like, crap, the timetable changed. And I said, no, it's Wednesday, Thursday. But anyhow, all right. So I think I can continue moving. I was somewhat delaying the process, trying not to go too far because boy, sure not have the time to go back, you know. So I think I can move straight ahead. I need to get some information from you though. How many of you were able to read through the notes sent? And how many of you were able to look at recordings?
I looked at the document that was sent, but I didn't
Mhm.
get a chance to look at the recordings.
Okay, fair enough. What are others?
For me, the document, I was doing notes in class.
Good.
I was doing notes in class or
Mhm.
writing it on have a little book or some foolishness. So I was practicing while you were teaching. So the document just reinforced what you said. But I didn't read anything else from the WhatsApp group.
All right, that's fine. Nikki, how are you? What's up to you? Were you able to do anything?
She said she wasn't able to look at anything. She's currently working overtime.
Oh, okay. Thank you. All right, thank you for You see, I said, I have a weakness. My weakness is sometimes I don't look at the chat. So thanks for pointing it out. Any case, I'm telling you, I want curry lobster and rice. When you get the overtime check, I want red wine and lemon marine pie. All
Sir,
right?
not talk too early. Maybe the government tax it. Don't do that.
All right, then you win. You win. All right. So we're going to be moving on. We're going to be moving on into into what it is that we continued looking at. Give me 2 seconds. Let me just. I thought I had thought of this. Give me a minute, please. Muting for a second.
Sir, your mic is mute.
Samsung come back.
Oh, I think he might talk to himself.
All right. The sharing device is taking its own time to come up, but it's getting there. Let me just warn you guys on something. So, ouch. It appears that the class is going to be very small. And I'm not lay with nobody. You know, understanding something, feel free to say, boy, sir, not understanding. Don't let it fester until I lose you. I'm going to ask that because what is happening is if, say there are 6 of you and 4 of you fail, them can't carry calculus 2 come next semester because them can't carry a class with 2 students with calculus 2. Can't do that. So I'm going to ask that you just be diligent, and which is why I ask you, if you got an opportunity to just go through. I won't kill you for the first week, but what you must do for me, I don't want you to come to any of my classes without doing a little bit of revision. Because for sure, I'm going to be building on the previous class. And I want you to be in a position to understand what is happening. So what I'm going to do, I'm going to take it as you guys understand how to do the intuitive approach, how to do the calculations method in evaluating your limits, which really and truly is not difficult. If you were to ask me, I don't know if you saw how I tried last week to develop the course, the areas. So in a nutshell, when you're looking at the intuitive approach, you have to look at the limit approaching from the left-hand side and the limit approaching from the right-hand side. If both limits are the same, you say that the function is of a good behavior and the limit exists. If it is not of a good behavior, meaning the left-hand limit is not equal to the right-hand limit, limit doesn't exist. The limit does not exist. Very important concept because, will I? Maybe tomorrow, God's willing, I will look at a different aspect of limits when I move up to piecewise functions. The same concept for the intuitive approach is going to be used for the piecewise functions. So you must understand what we did last week in order to move on from tomorrow, because that's exactly what we're going to be doing again. And then we look at the calculations method. The calculations method is you assuming that the limit is equals to what the function is tending to. And just go ahead and substitute that limit into the function. Having done so, you're going to evaluate the limit. So you don't have to look on the left-hand side or the right-hand side. And then what I was able to look at with you is to look at something that we call the indeterminate form. Now the indeterminate form is where we have either 0 over 0, or we have infinity, positive infinity over positive infinity, or we could possibly have negative infinity over negative infinity. So there are 3 possibilities. When the function, and of course these are rational functions. These are rational functions. So what we call rational functions again, these are functions that have a numerator and a denominator. These are functions with a numerator and a denominator. Pretty much what we're saying is a function that has a fraction. It's a function that has a fraction. So that's what we're going to be doing. So when we evaluate the numerator, if it comes out to be 0, we put it down. We're going to evaluate the denominator. If it comes out to be 0, we're going to put it down. And then we're going to say, whoa, 0 over 0. Indeterminate form. Hear me out clearly. It does not end. The calculation does not end right there. a lot of students and I fight every year that I'm teaching calculus 1 or I'm teaching business calculus. The students and I fight continuously because once you hear that it's indeterminate, you think the question done. No, no, so. Hold on, let's change the device. Change. All right. So I want you to always recognize that when you get the indeterminate form, it is just that, the indeterminate form. The indeterminate form is telling you there is something in the function preventing the true limit of the function from coming out, therefore I must do something. Can anybody remind me what we did last class to get that function out? I'm projecting. So we got 0 over 0 there, the indeterminate form. What did we do?
Factorize, sir.
Hello?
I was saying we
What are you hearing me?
factorize, get it out
Oh dear.
to the extent.
Anybody hearing me at all?
Sir, you're not hearing me?
Yes, I'm hearing you.
Am I not being heard? Anybody hearing me?
Yes, I'm hearing you.
Hearing you also.
Answer me now.
But sir, I was answering. Ask the question again.
Oh, I'm not hearing you guys. Oh, hold on. Hold on. Somebody speak again, please.
1, 2, 3. 1, 2, 3.
Okay, yeah, I'm hearing you now. All right, thank you. So you heard, okay, so I was asking the question. So last week when we got the indeterminate form, I did something. Can anybody tell me what it is that I did?
I was saying that you factorize, sir.
Very good, my love. Very, very
You
good.
weren't hearing.
So I factorized. I wasn't hearing you. Thank you. So I factorized. So you're always going to do it? Yeah. Yeah. You're going to do one of 3 things, either factorization, a simplification, or a rationalization. So when you get the indeterminate form, 0 over 0, it not done this stuff. It reach right there, so no, just say, okay, fine. You know, like when you go to a doctor and doctor say, and that's why it's not very good to lie to a doctor. And a teacher can be considered a doctor. And I'm going to show you the similarities. When you lie to the doctor and say, okay, what are your symptoms? You know, one day the doctor say, I really ache, you know. And you withhold that critical information. No, you just telling the doctor, boy, my tummy hurting me now, could give the correct diagnosis. And then the doctor knows going to give you medication with an incorrect diagnosis because you withheld something that was very critical. In your headspace, and I'm not in that. You did drink the spoiled milk yesterday, so it a worky belly. And then you recognize 2 days in it, 3 days in it, until sometimes the situation becomes irreparable and you have to become hospitalized. Similarly, when teacher says to you, do you understand? Yes, sir. You know to God say you don't understand. Are you sure you're understanding? Yes, sir. You can move on, sir. And when sir move on, and sir ask a question, sir recognize you don't understand nothing. So it is very important that in this relationship we speak the truth and speak it ever, cause it what it will. He who hides the wrong he did does the wrong thing still. And that's the truth. If you hide the wrong stuff that you do, you're going to continue doing the wrong stuff, believing that you're right, and you're not going to get the question right. Right? So it's very important. So there are one of 3 things. So when you reach the 0 over 0, it's one of 3 things that you have to do. in order to find out whether or not the correct limit of the function. Because you get 0 over 0, you say, sir, 0 over 0 equals 0. The limit is 0. No. You have to do a factorization, a rationalization, or a simplification. Now, the truth of the matter is most of the questions come with a factorization. Most of the questions come with a factorization, but I'll show you there. And then when you do that now, you'll be able to isolate what it is. So the doctor says, okay, so you're not having loose bowels? No, doc. You're not bringing up mucus? No, doc. The doctor says, okay, so I can definitely rule that one out because that's not it. And then he moves on with the next diagnosis. All right? So we're going to factorize. Now, what teacher did last week was to write out method, because I never had this in the notes. But before I set the notes, I say, you know what, let me just go and type out something for you guys. So to factorize x squared minus 5x plus 6. And I want you to look at it again because I'm doing this revision because you're going to be doing some work for me. X squared minus 5x plus 6. It says you're going to multiply the coefficient. Uh-oh, that's the number in front of x squared. What number is in front of x squared again?
1.
Thank you, please. You're here. Welcome, Shelly. And then now it says by the constant, which is a constant now?
The
What's the
number
constant?
without the X.
The number without the x. All right. All right. Can you write that at the top of all of you? I want you to write that at the top of your notebook, please. Whatever page you're at in your book now, I want you to write that for me. The number, the constant is a number without the x. I'm going to come back to it. I'm not going to stop the lesson just yet. I'm going to come back to it. The number without the x. So I asked what is the constant, and I heard the number without the x. And for now, I'm going to agree 100%.
You came in and out.
I'm in and out.
It's my internet, but you were saying that we're supposed to write what at the top of our page. The one
The
before
number,
the X
no,
square?
no, and the number, the constant, somebody said to me that the constant is a number without the x. You follow what I'm saying?
Yes, sir, that was me.
Right. So I want you to write it at the top of the book for me. The top of the page,
Okay.
because I'm going to come back to that statement sometime later. For now, it is fully correct. For now, it is fully correct. Fully correct for now, but I'm going to come back to it because there is something that I need to talk to you about as it relates to that, right? So yes, somebody said no, but in front of the x, without the x. All right, hold on half a second, please. All right. So have you all written the number without the x on the top of your page?
Yes, sir.
Nice. As I said before, for now, it is a perfectly correct answer. We'll come back to it a little later on. No. Something. Right. So I'm going to multiply the coefficient of x squared by the constant. So 1 times 6 is 6. So this is what you should be saying to yourself. I need two numbers. When multiplied together will give me 6, which is a product, which is a product.
So you're asking us to respond?
No. I'm seeing where I can beef up this thing. I'm just trying to help you out with the notes. So I'm trying to beef it up. So we need two numbers and multiply together will give 6, which is a product. 1 times 6 is 6, that's a product. But when added will give you -5, the middle term. Right, which is the middle term. So the factors are going to be -3 and -2. Because when I multiply -3 by -2, I get +6. But when I add -3 to -2, I get -5, thereby replacing the middle term with -3x and -2x. I'm going to pause here for a minute and ask the question, are you understanding?
You say if we're understanding, sir? Yes, I'm understanding.
Thank you, my lord. Want me to raise the honor?
Sir,
Yes, Pops.
why could it be 1 or 6, 1 and 6?
1 and 6? Okay, very good question. And that's why I stopped the class to ask if you're understanding incidentally. So the question is being asked. Very good question, as a matter of fact. Sir, why couldn't it be 1 and 6? Because let me ask him, let me not jump into his head. Why are you asking why it couldn't be 1 and 6? Let me see if you're actually where I think you are at. Why you ask that?
Sir, because it's a 1 times 6 equals 6. And when you said 6 subtract 1, you can get the 5.
You get
So,
6 subtract 1, you get 5. But what kind of 5 I want, Chevy?
negative. So 1 minus 6 give you a -5.
Okay, all right. So let us work with Chevy just now. So he's onto something. He's saying, we just say 1 minus 6. But I'm going to ask a question now, Chevy. What kind of 1 it is? +1 and a -6?
Yeah.
All right. But when you multiply +1 with a -6, what you get?
-6.
All right. Is -6 a 1 or I want a +6?
+6.
That's not good.
Oh. Oh,
That's how you ask the question because that's where I was going. So a lot of students would say, sir, no, 1 minus 6 is -5. You have a middle term. I sure do.
right.
But when I try to multiply, what am I going to be getting? I'm going to be getting a middle term that is not going to be, I'm going to get a product rather that is going to be different from what it is that I really want. Because the product is going to be -5. When in fact, I want a -5. The product and a +6. Are you follow what I'm saying? Yes, no? You guys are responding to me. The response is very delayed. Am I coming across clearly?
Yes, sir.
Are you being distracted? Is there something that is preventing you from fully learning this? I don't want, when I give you one on your own, it poses a difficulty. I'm going to ask that you give me your undervalued fee. Very, very important that I get your undervalued. Call me selfish? I don't care. I want your undivided attention. All right, so let's go. So Shelby, you understand now why I can't use 1 and -6? Because when I multiply 1 with -6, I'm going to get a -6. But my product is supposed to be a positive 6.
A positive 6.
That's the reason. And very important reason to can't leave that one out. That's the very, very, very important reason. Any other questions?
Sir, why do you use the term, sir?
I'm hearing you.
Why do you use the term grouping to give?
Why do you use the term grouping to give?
Yeah. I'm not hearing you, sir.
Is there are you having a difficulty hearing me, class?
If I'm finding a difficulty hearing you,
No, I know
sir,
your
remember I'm
internet
using
is.
it.
Yeah, I know yours is unstable, but the others are not answering me as well. So I'm wondering if this
Yes,
I am the
sir.
problem.
Yes,
You're having
yes. Yeah,
you're having a
you
difficulty hearing me?
yes, you go in and out sometimes are very low.
All right. Okay. So say that then. All right. Am I coming across much clearer now?
Yes, sir.
All right, good. All right. Wanted to write something for you, but all right, let me look at it. Let me look at it when I give you the piece of class assignment. It should be asked a question, and I'm looking for my writing pen and found everything else away from the pen. So I have one other place to look. So I'll wait until I give you an exercise, since I'm going through the revision here, to ask you to look at that for me. Okay, now, so I'm in a group now. I'm in a group. Remember, I'm replacing technically the -5x with -3x and -2x. I'm replacing the -5x with -3x and -2x. Technically replacing those, -3x and -2x. So I'm not interested in the -5 again. Now it's going to be -3x and -2x. So I'm going to be grouping. When I group, and there's another reason why I have to group, why I have to split it. Because when I group, I'm factorizing by the grouping method. So that's what it means. Somebody was asking, what do you mean by grouping to give? I'm doing the method of factorization by grouping. So in order to group something, I can't group these 3 terms, because if I group these 3 terms, one grouping is going to have 2, and the other grouping is going to have 1. So I have to break up the middle term into two terms. So when I group it, I'll have two terms in each bracket. I'll have two terms in each bracket. Very important. Very, very, very important. So look at what I'm going to do. I'm breaking it up. I'm breaking it up to say but breaking it up to say negative 3x in one bracket. So I'm putting these two in one set of brackets, and the last two in another bracket. Always leave the middle sign out. 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 Every single time. But watch me. When the middle sign is a negative sign, this last sign here has to be flipped. When this middle sign here is a negative sign, the last sign has to be flipped. Has to be flipped. What do you mean by that, sir? This sign has to be flipped because when I multiply this negative number by this positive 2x, I get negative 2x. When I multiply this negative number by this negative 6, I'll get that my positive 6. So once the middle sign is a negative sign, flip the last sign. Okay, sir, tell us a story. If it is positive, leave the sign alone. If it is positive, leave the sign alone. Sir, what is the rule of thumb? When it is positive, you can call it positive. When it is negative, put some title on the man's name, Mr. Negative. When it is positive, you can call him positive. You know the Shreps don't. But when it is negative, Mr. Negative, how are you doing? It's very important that you respect the negative sign. In everything that we do, very important that you respect it because it is very special. Okay, let's go. So I'm going to say to myself now, what is common in this term that is common to this term? What is common to this term that is common to this term? What is common is, and your answer is?
X.
And that's why I factor out my x. Very good. And that's why I factor out my x. And when I factor out my x, I'm going to ask the question now. What is left? Sir, what do you mean by what is left? Okay. What do I multiply by this x to give me x squared? And you will say, sir, an x. I said, great. And then I'll say to you, what do you multiply by this x to give me a negative 3x? And hopefully, you will tell me negative 3. So I'm going to have negative 3 being negative 3 left. I'm going to have negative 3 left. So technically, I'm going to have 3, open bracket, x minus 3. 3, open bracket, x minus 3. I'm doing the same thing to this side. Still respecting the negative sign. I'm not interfering with it. I'm putting some respect to the sign's name, Mr. Negative. I put him back. Then I ask myself a question, what is common to 2x? That is common to negative 6. And your response to me should be 2. So the number out here now becomes negative 2. And then I'm going to ask the question, what do I multiply by negative 2 to give me this negative 2x? It's going to be an x. And what do I multiply by negative 2 to give me a positive 6? When I multiply two negative numbers, I get a positive number. So this number here has to be negative, and 2 times 3 will give me 6. Now I'm finished with my factorization, semi-factorization here. Just need to point out to you. Do you recognize that the same thing in this parentheses is the same thing in this parentheses? Do you?
Yes, sir.
And if they are different at that stage, it will be incorrect. If you had two different set of stuff in the parentheses, you'll be wrong. It must be the same. Sir, why? Because of my next step. I'm going to ask, what is common here that is common here? And I would hope that you say it's going to be x minus 3 that is common. So I take out my x minus 3 right here. Then I'm going to ask the question, what is left? When I remove x minus 3 from here, I have only x left. Talk truth. Hello, somebody?
Right here, sir.
But me want you responding now. I want you to respond because I want to know that you are there. All right? So I'm going to take out the x minus 3 from here. What I'm going to left with is a negative 2. So see this x right here, and this negative 2 is right here. So my product is going to be x minus 2 times x minus 3. X minus 2 times x minus 3. And if you want, we can check it. X times x is x squared. Right, it's too far up. X times x is x squared. And x times negative 3 is negative 3x. See it right here, so. And negative 2 times x is negative 2x. See it right here, so. And negative 2 times negative 3 is positive 6. See it right here, so. And then I can go a step further. Negative 3x minus 2x is going to be a negative 5x. I get back what I started off with. X squared minus 5x plus 6. All right? So I'm going to replace my original question says x squared minus 5x plus 6 over x minus 3. So I'm now replacing x squared minus 5x plus 6, this question, with a factorized form. And when I look clearly, I can make my conclusion. My x minus 3 was what was preventing the true limit of the function from coming out. The x minus 3 is what was preventing the true limit of the function from coming out. So I'm going to cancel it out. I'm removing it. I'm isolating it. I don't want it to be nowhere near me because it's going to make my answer wrong. So what I'm going to be left with is simply the limit as x tends to 3 of x minus 2. Now I can apply the calculations method. Calculations method says that I'm going to assume that x is equal to 3. So in x minus 2, I'm going to put x equals 3, and 3 minus 2 is equals to 1. So the limit of the function tends to 1. And that's the end of the question. Now that's where I stopped last class. True or false?
True.
All right.
True.
Are there any questions? Okay.
No, off the top of my head.
I want you now to evaluate that limit for me. I want you now to evaluate this limit for me. I want you to evaluate this limit for me. Quick, accurate, and fast. Quick, accurate, and fast. So I'm going to give you 3 minutes to do the stuff, all right? Now you have the document that you can refer to. So I'm going to mute and give you 3 minutes to complete this question for me.
Sure.
Yes, love.
Sir, before you mute, the limb x to 3, and then the top and the bottom, do we have to have that in the final response?
This one here?
No, the first one that you were pointing
This
on.
one? If you have to have this?
Yes, and the one below
Yeah,
it.
yeah, man. For you show them, you know, you remember get marks for your steps, you know. So you want to show them, say you cancel out this, so you only left it now x minus 2, right here, so. And you show them now, so you substitute the something right here, so. So 3 minus 3 is equals to 1.
All right. So.
Yeah, man. Thank you for your question.
Sir,
Yeah.
sir, why is it that the work always harder than the example?
Uh-oh. Uh-oh.
Sir, my last now, you know, because I don't know if I go from the angle.
All right. Did you get that to be indeterminate?
Sir, nothing with that.
No, man, remember what do you do in order to get something to see if it is indeterminate? Tell me.
I think we equate it to 0 or take the algebraic approach. So what I do is substitute 4 for the x. So then that's just where it's at.
So what you got when you do that?
5/4 to the second power minus 4 squared minus 1.
Okay, and what when you get that, what it work out to be?
What? Say that again?
What when you work
When I
when you
get
work
that?
out that? Yeah, what do you get when you work that out?
I just left it there. And then I'm like, okay, maybe I could say 5/x bracket x minus 1.
Wait, question, sir. I'm on the same path that she's on, but I got the multiply the 4 squared, so I get 16 minus 1, which is 5/15.
Which is the same thing as?
0.333333.
And as a fraction it is?
5/50.
In its simplest form is
1/3.
good job. That's what I have on the system on the board.
Yeah, 1/3.
All right. So what I did just now, AC, is to
Complicate things.
is to put the question on the board to see if it is that you are following my methodology. And methodology was, or the instruction was, if you are given a question that is rational, meaning something with a numerator or something with a denominator, the first thing you're going to be doing is using the calculations approach by substituting the value of the function of where it is going, the limit, into the function. And if you get 0/0, then you know that it is indeterminate. If you get 0/0, then you know that it is indeterminate. If you don't get 0/0 and you get something like 1/3, that is the answer. But sir, you do something different. No, it's the same methodology. What was the method? Substitute the value into the function to see if you are going to get 0/0. But when I substituted it, I'm getting 1/3. So is this question of the indeterminate form? Yes or no?
No, sir.
No, it's not. So what I'm doing is not to confuse you. I'm trying to help to develop in you the critical thinking that I want you to have and that you will be required for you to complete this course and to pursue the next. So just follow my instructions. And you follow my instructions, you're good to go. So that answer there is 1/3. All right. So since you did not get the 0/0, it suggests that the question is not indeterminate. Therefore, no need to factorize, simplify, or rationalize. Question done. Question done. Any question?
No, sir. I think so.
And while you do, now I want you to try that. Now, while you think back, I now want you to try that one on the board. The limit as x tends to -1 of x plus 1 over x squared minus 1. You recognize that the function is the same. You recognize the function is the same, but the limit now is different. The function is the same, but the limit now is different. All right? Run that.
Then, sir, you write question done this, so we're supposed to write question done too?
No, you're going to write
Hmm.
QED.
Really?
What is QED?
I don't know.
Quite easily done.
Which one?
But if you ever write that enough, make sure you say the question right.
So that's a
I'm gonna,
glitter.
I'm gonna laugh it to scorn. Aye. Man, but
Sir,
yeah. Uh-huh.
next time go write QED and it's incorrect.
Dark truth. Me laugh it to scorn. Me I'll come to class, come and load you up. When you write QED, you must be sure. You must be positive. All right. Try that one for me, please. And let us see what is going to happen. And there is something in the example two that I did that you're going to be needing to do in this third example. I'm not going to say it. I'm going to see if you can transfer that knowledge. All right, 3 minutes.
I think I'm finished, sir.
Very good. What about the others? All right, I give another minute or two to the rest of you. Another minute or two. How is the? AC, did you get the indeterminate form?
No, sir.
You didn't get the indeterminate form?
No, I got 0/2.
Hello, mom. It's when you square -1, you can get +1 here. Because -1 square means you can multiply -1 by itself. So it's -1 times -1. So you can get +1.
Positive. So it would be +1 minus 1. Oh, so that
Oh,
is
true.
0.
Yeah.
Oh. Oh boy.
Don't worry
Alright,
about
sir.
it. Don't worry about it. I want you to continue working for me, please. The rest of you, are you working? I'm going to stop you here because I didn't do that solution. I only wrote the question, but I didn't do the solution. So I'm going to try and do the solution quickly before we end class. Are you okay with it so far? All right, no answer. So I guess as I guess.
Sir, application is an issue. So when we get the 0/0, we move further from there,
Yeah, man.
factorize it.
Right. But what are you in factorize now?
Sure, that may I try to figure out. So factorizing x plus 1.
That is
X
already in
square
its
minus
simplest form.
1, sir. Say
X
that
square
again?
minus 1. The x plus 1 is already in its simplest form.
The x square minus 1 is all factorizing.
Right. So let me just show you where I've gotten to. I didn't do the question, so I'm doing it now as we speak. So that's what I got. Now look at what it is that I have there and tell me if you agree with me. I'm substituting the value. I'm using the calculations method. So I'm substituting the value into the terms of the function. And when I do that, I'm going to get -1. -1 plus 1 over -1 square plus 1. And -1 square plus 1 is going to be -1 square is going to be +1. Because -1 square is -1 times -1. So you're going to have +1. And +1 minus 1 is going to be equal to 0. So I've got my indeterminate form. There's something in the function preventing the true limit of the function from coming out. There's something in the function preventing the true limit of the function from coming out. So I need to factorize. But when I look at my numerator, I recognize that my numerator is in its simplest form, x plus 1. But my denominator is x squared. And that's
2 spaces, compound, big, complex.
You should recognize that as a special form of factorization, what is that known as?
By grouping?
Yeah, you can use it by grouping, but that has a special name.
I can't remember right now.
It's the difference of two squares.
Oh, yeah.
Anybody remember hearing that? The difference
Back
of
in high
squares?
school. High school.
All right. So what I was saying earlier is that there is something up here that is going to help you in doing the question. So my x squared minus 1, when I factorize my x squared minus 1, I'm going to get x minus 1 times x plus 1 because it's a difference of squares. So when I have x squared minus 1, and then the question may be, sir, how do you recognize or identify the difference of squares? Thanks for asking. The difference of squares is so identified because it has exactly two terms. An x squared term, or I should say a squared term, plus a constant separated by a negative sign. Sure, could it be positive? I said separated by a negative sign. So once we have a squared term, it could be y squared minus 1. So the first term is a squared term. The last term is normally a perfect square, like the 1. What I call a perfect square, sir? A number that when you multiply by itself, you get that number. For example, 4, I multiply 2 by 2. 9, I multiply 3 by 3. 16, I multiply 4 by 4. And so forth and so on. So the only difference is that one of them is going to be positive and the other one is going to be negative. So that's what we call difference of squares. That's what we call difference of squares. It's not a perfect square. It's not a perfect square. A perfect square would be, for example, x minus 1 times x minus 1. It means that we're in the first bracket, in the second bracket. Or it could be x plus 1 times x plus 1. The difference of squares, on the other hand, is where the terms are the same, exactamente. The only difference is one term is positive and the next term is negative. That's what we call the difference of squares. All right? So when you factorize it and get the difference of squares, no, that's what I'm going to do. I'm factorizing the denominator. You notice in the first one, it was the numerator that I factorized. I'm going to be factorizing the denominator. When I factorize the denominator, I'm going to get x plus 1 times x minus 1. All right, continue there for me, please. I have a few minutes. I want to finish off this question. I stopped sharing because I want you to work while I work. Talk to me. Calculator. Mhm. Mhm. Come on, guys. I'm talking to you, you're not responding to me. I have 2 minutes.
Sorry, you were saying something before? Because you said you were gonna work while we work. This is the first thing
So I was asking how to stay now. But we have 2 minutes left.
Oh, didn't hear
I
you
finished your
before.
question. You finish? Anybody finish?
Sir?
Mm-hmm.
Sure.
Mm-hmm.
Sir,
Finish? No? Yeah?
I get negative half.
Very good. Excellent. Excellent. And I tell you, if there's something not hard, you come to my class, you focus, and you try, you're good to go.
Sir,
Yes, my love.
I got kicked off.
Never mind. I was just
No,
responding to the answer that was just suggested, negative a half. So remember now, we need to factorize the denominator this time. The numerator is in its simplest form. There's nothing to do to the numerator. It's just the denominator we need to work with. Just the denominator. So I'm going to factorize the denominator. As I showed you before, the x squared minus 1 is the difference of squares. So it becomes x minus 1 times x plus 1. And what I'm going to be doing is just rewriting my question. X plus 1, which was what was given in the numerator for the question. And then instead of having x squared minus 1 in the denominator, I'm going to replace it with x plus 1 times x minus 1. Replace it with x plus 1 times x minus 1. And then you recognize that the x plus 1s cancel out. So I'm going to be left with 1 over x minus 1. Now that I've removed what is causing the problem, I can now go back and substitute the value of x into the function now to see what will happen. And for sure, I know that I'm not going to get an indeterminate form this time. So when I substitute negative 1, the numerator remains the same because there is no x value for me to do a substitution. So it remains the same as 1. But the denominator now has x minus 1. But in this case, I'm substituting x for negative 1. So it now becomes negative 1 minus 1. And when I add those two numbers, I'm going to get negative 2. So I could write my answer several ways. Negative a half, that's way number 1. Way number 2, I could write it negative 1 over 2. And way number 3, I can write it 1 over negative 2. All three of them gives the same number of marks. They're all correct. All right? Just make sure that you have that negative sign. The negative sign can be in front of the whole fraction. The negative sign can be in the numerator. And the negative sign can also be in the denominator. It makes the whole fraction negative. It doesn't matter. It really doesn't matter. Really doesn't. And that brings us to the end of the class. Are you okay?
Not so much okay. I think I'm gonna have to go back to this question And I
Please
think
do.
I need more practice.
Please do.
I'm
What I'm-
hoping that my internet will be restored tomorrow because my data is not doing that much justice.
Right. What I'm gonna do, I'm gonna see if I
Yeah.
can send this off a little later on. I have a slight pain to the head, so I'm just gonna cool off a little, and then I'm gonna send this off tonight, and with a question, with just one question for you to try. Please give it a try for class tomorrow. I beg of you. Give it a try for class tomorrow. All right. Have a good one, guys. All the best.
Okay, sir. Good night.
Bye bye.